In this video, we're talking about solving equations with distributing and combining like terms. A lot of these, most of them will have a fraction with it as well because it's always nice to be able to get rid of a fraction. So for the first one, let's do 3 is equal to 5 halves, parenthesis 3x minus 2, parenthesis. Now, you can think of this in two different ways. How I think of it is I think of the top times the whole number, and then we divide it by the bottom number. So I think 5 times 3 is 15, divided by 2 is 15, divided by 2, 15 halves. 5 times 2 is 10, divided by 2. So I go 5 times 2 is 10, divided by 2 is 10 halves. And I'll show you another one here in a minute where I show you a different way to do that. But that's how I like to do it. Totally okay if you have a different way, as long as it works every time. So I've distributed my 5 halves through my parentheses. I'm gonna check my signs. So a positive times a positive is a positive times a negative is a negative. And now I bring down everything I have. So I can see here that I have a common denominator. I want to make this into a common denominator. So currently it's over 1. So I need to times it by 2, times the bottom by 2, times the top by 2. What that does is it really gets us 6 halves is equal to 15x halves minus 10 halves. Because all of the denominator is the same, we can disregard them. So now I'm just working with a two-step equation. So if I add 10, I get 16 is equal to 15x. I'll divide by 15, and this will actually be my answer. It's also 1 and 1/15, but I think a lot of the times they prefer it left as an improper fraction. So you'll keep it as 16/15 is equal to x, all right? That's the first example. Now the next one is gonna be, let's do 16 is equal to 1/2 parenthesis 7x plus 8. So the other way you can think of distributing a fraction through is you think of each of these as their own fraction. And whenever we are multiplying fractions, we just do top times top. So 1 times 7 is 7, bottom times bottom. 2 times 1 is 2. And then we'll do, so we distribute this to this fraction. So that becomes 7 halves, x, and we distribute it to this fraction. So 1 times 8 is 8, 2 times 1 is 2. And we check our signs again. So a positive and a positive is a positive, a positive and a positive is a positive. It's equal to 16. Now this is 16 over 1. Because these two are already a 2, we can just take this one and times it by 2, and that's going to give us 32, technically over 2, but we'll get rid of it in a minute. 7 over 2x plus 8 over 2. Because we have that common denominator, we can kind of disregard it, and now we can do our two-step equation. So minus 8 minus 8, and then 32 minus 8 is going to be 24, is equal to 7x. So now these two are multiplying, so you are going to want to divide to get rid of it. So we'll divide to get rid of that. And when we divide it, it won't reduce and it doesn't go evenly, so our answer will be 24/7. If it was a mixed number, it would be 3 and 3/7. So this is the same value as this. It just depends on what form it wants. Both of them are equal to x because they're the same value, just a different way to write it. All right. So that's one way you can think about distributing a fraction through. Now, the next one, we are going to distribute a negative through parentheses. We have a negative, and then it's right next to parentheses. X plus 6 over 5. So what I want you to notice is this. Whenever we have something that, like an X, and it doesn't have a number there, we know that that number is 1. Well, the same thing happens when a negative is touching parentheses. It's actually a -1. So we will distribute this -1 through to both of these values. And what's so great about a -1 is that it just changes, it doesn't change the number of either of them, it just changes the sign because it's a negative. So a negative times a positive is a negative, 1 times 1 is 1x. Negative times a positive is a negative, 1 times 6/5 is still 6/5. So it just changed both of these positives to negatives. But I have it distributed now. I still have my 1/2 and it's still equal to 6/5. What I'll notice is this. I have fractions, I have a different denominator. This one is really over 1. It would be 1 over 1, totally okay. I can get my common denominator, which is 10. I can see that 5 and 2 both go into 10. So I'll times this by 2 to get it to 10, this by 5 to get it to 10, this by 10 to get it to 10, and this by 2 to get it to 10. And what that does for me is it makes it so I don't have to worry about the denominator. I just have to worry about that top. So 12 is equal to 5 minus 10x minus 12. So now it's a matter of combining like terms. 5 minus 12, so 5 positives, 4, 5, 12 negatives, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Each of those ones cancel out. You should see that you have more negatives. So I have 7 more negatives. You can see it right here, 1, 2, 3, 4, 5, 6, 7. So I have 7 more negatives. That is going to be the answer when I combine those. And then I drop what I still have on that side. This right here is 2 steps. My first step is getting rid of what's not with my variable. This is my stranger. Add 7. I have 19 is equal to a -10x. And then divide by a -10. By dividing by a negative, it gives me a +1, which I need my x to be positive. So divide by a negative. This will be my answer. It will stay 19 over -10. Or negative, you can just say it's a -19/10, because a negative anywhere, whether it's at the top of a fraction, the bottom of a fraction, or at the side of a fraction, it just means that that number's value is negative. So it doesn't really matter where it's at. Okay. Let's do one more. Let's do one with some numbers on both sides. So let's do 3 times 3/2 x plus 2/3 parenthesis minus 8 is equal to a -3/2 x. Nope, 3/2 plus 7x. Okay, so now we have to work with fractions. We have to have variables on both sides. So this is going to be putting all of it together. If you can do stuff like this, then you'll be fine working with the equations that we'll run into during the year. Now, remember that one technique where it's putting the outside number as a fraction and we can just multiply it by fractions? So that's what we'll do. 3 times 3 is 9, 1 times 2 is 2. And we have an x there. Plus 3 times 2 is 6, 1 times 3 is 3. Now, I have just distributed that through those parentheses, so this has been used and those have been used, so I don't have to deal with that anymore. I do need to drop down what I already have. It's equals to -3/2 plus 7x. Now, what you'll notice is I have a couple of fractions and then a couple of whole numbers. I can turn them all into fractions and find my common denominator. In this case, my common denominator is going to be 6, okay? And so I need to be able to see what needs to happen in order to get the denominators to 6. 2 times 3 will be 6, so I have to times the top by 3. 3 times 2 will be 6, so I need to times the top by 2. 1 times 6 will be 6, so I have to times this top by 6. 2 times 3 will be 6, so I'll times that one by 3 and times that by 6, okay? once I can see that my denominator will all be 6, I don't have to worry about it anymore. I just have to worry about those top numbers. So 9 times 3 is 27x. Please don't lose your variable. That causes some problems. Plus, 6 times 2, I was going to do 6.2. 6 times 2 is 12 minus 48 is equal to negative 9 plus 42x. All right? At this point, we've gotten rid of all of our fractions, and really it's just a matter of combining our like terms and then moving them across the equal to sign. So if we combine these, you'll notice we have 48 negatives and we have 12 positives. We have more negatives, we have 36 more negatives. So that's gonna be our answer when we combine those. Or you could just do what the numbers tell you to do. 12 minus 48, you get a negative 36 is equal to. On this side, we don't have any that we can combine, so we'll just drop it. And now we can move things across our equal to sign. I recommend that you move your variable first. If you move your variable first, you can start moving things away from that. It looks like a two-step equation here in a minute. So let's minus 27x, 42 minus 27 is gonna be 15x, and then I drop everything else down that I haven't used. Now this 15, the sign in front of it, I have more positives than I do negatives. I know my answer is going to be positive, so that's how I determine that sign. Now I have to do my 2 steps. This right here is a 2-step equation. We can add 9, we get a negative because we have more negatives. 27 is equal to 15x. Then you divide by 15. Over here you'll divide by 15. If ever you can reduce, then you should reduce. It's always good to simplify. In this case it won't, so that would be our answer. All right.